Hello, and welcome to this presentation, Getting Started with the NPA Power Analyzer. In this presentation, we'll show how to use the Rohde Schwarz NPA Power Analyzer to perform a wide variety of power-related measurements, including power factor, inrush current, standby power, and harmonics measurements. This presentation assumes a basic familiarity with electrical power and various electrical power measurements, so please see these separate presentations on power measurements if you'd like a brief refresher on any of these topics. We'll start with an instrument overview. The Rohde Schwarz NPA is a family of standalone, compact benchtop analyzers that measure and characterize both AC and DC power. The NPA 101 provides basic numerical measurements, whereas the NPA 501 supports a wider range of both numeric and graphical measurements, including advanced analysis functions such as inrush current, harmonic analysis, etc. In addition to these measurements, the NPA 701 adds automated conformance tests for both standby and harmonics measurements. The NPA is directly controlled via a simple and intuitive user interface, but it can also be accessed and controlled remotely. Measurement data can be logged and exported in easy-to-process CSV files. The first step in using the NPA is connecting to the device under test, or DUT. This can be done directly using the 4mm safety jacks on the front panel. Voltages are measured using the red V jack, currents are measured using the blue A jack, and the black COM jack acts as a shared measuring input for both voltage and current. As indicated on the front panel, the NPA can measure up to 600 volts RMS and 20 amps RMS, although the current range can be significantly extended using an external current clamp or shunt. Note that for safety purposes and to avoid instrument damage, the NPA will automatically shut down if these limits are exceeded. In many cases, the connection to the device under test is made by means of an AC mains adapter, such as the NPA-Z. The DUT is plugged into the adapter, and then color-coded cables connect the AC plug contacts to the appropriate plugs on the NPA. Different versions of the NPA-Z are available to support the different AC outlet types found in different regions of the world. Next, we'll cover basic navigation and configuration of the NPA using the front panel controls. A set of 5 soft keys are provided for menu navigation and parameter configuration. Each button corresponds to the menu item shown to its left. There's also a back or escape button, which is used to exit or close menu items, as well as to dismiss dialogues or messages. Although the NPA can automatically set voltage and current ranges, manual configuration of these ranges is also possible using the front panel U and I keys. Numeric values can be entered and/or modified in 2 ways. The Shift key activates the numeric keypad for entering numeric values, and the rotary knob and cursors can be used to both select menu items as well as to modify numeric parameters. 2 important keys for configuring measurements are the Data Acquisition menu button and the Measurement Configuration button. Both of these menus and their functions will be described in detail later in this presentation. 2 additional helpful keys are the Hold key, which pauses update of the measured values, and the Reset key, which resets or restarts a running measurement. Administrative functions are also accessed via the front panel controls. The Setup key is used to configure instrument setup, such as screen brightness, interface addresses, etc. The Save Recall key is used to save and load instrument configurations, and holding this key down will take a screenshot. The NPA also has an integrated Help function accessible via the Help hard key. The first step in making measurements with the NPA is selecting the measurement mode using the View hard key. The 5 different measurement modes are Numeric mode, Waveform mode, Trendchart mode, Inrush mode, and Harmonics mode. Let's look at each of these modes in more detail and explain how they're configured and used, starting with Numeric mode. Numeric mode is a default display mode and provides continuously updated numeric values of measured parameters. Due to the large number of measurements supported by the NPA, these values are presented in 4 screens. The number keys on the right can be used to move between the measurement screens. Note too that each screen can display either 6 values, as shown above, or 10 values, as shown below. Pressing the number key twice is used to toggle between the displays. It's also worth noting that the top of the screen also shows important configuration parameters, such as the voltage and current measuring ranges, the operating mode, AC or DC, the elapsed measurement time, whether logging has been enabled, and the selected remote access method and status. Let's look at some of the numeric mode measurements. On the first screen, we have the instantaneous RMS values of voltage and current, the active, apparent, and reactive power, as well as power factor. The voltage and current ranges, here 150 volts and 1 amp, are displayed as bar charts showing the instantaneous values as a function of range. On screen 2, we have the average, positive peak, and negative peak values for both voltage and current, the frequency of voltage and current, and the total harmonic distortion of voltage and current. In numeric and other modes, the acquisition button provides access to various measurement parameters. The voltage and current buttons can be used to set the range and enable or disable auto-ranging, and crest factor can be increased if needed to measure signals with large spikes. Mode is primarily used to choose whether measurements are made on AC or DC. The NPA can also determine this automatically. Additional mode parameters can be adjusted if necessary, but in most cases the default values are sufficient. The peak hold button can be used to activate peak hold or to reset the peak hold period. And finally, the refresh range can be changed from its default of 10 values per second to a single average value every second. The next mode we'll look at is Waveform mode. This mode provides a graphical view of voltage, current, and/or power over one waveform period, similar to how these would be displayed on an oscilloscope. The period is automatically determined by the NPA. An automatic hardware-based trigger is used to start each acquisition, and the waveform is continuously updated. Vertical scaling of the waveform can be done using the I and U keys on the front panel. In addition to displaying the waveform, the NPA also provides numerical results for RMS voltage, RMS current, and power, with soft keys being used to choose which traces to display or hide. Let's use waveform mode to compare a traditional 60-watt incandescent light bulb with a 60-watt equivalent LED bulb. On the left, we see that current, voltage, and power are all in phase for the almost entirely resistive 60-watt incandescent bulb. But on the right, we see that the LED bulb draws current, the red trace, in a nonlinear fashion, which also causes power, the green trace, to be nonlinear as well. We can use the numeric power results to see that the incandescent bulb consumes significantly more power than the LED. 62 watts are being consumed by the incandescent versus just 8.6 watts by the LED. Trendchart is another graphical mode which allows up to 2 measured values to be plotted as a function of time, in a way similar to roll mode on oscilloscopes. Trendchart mode is used to look at longer periods of time. 40 seconds to 80 minutes of data can be shown on the screen. The user selects which values to plot and the time base, but the vertical trace scaling is handled automatically. While running, the max and min values are displayed numerically on the screen, and the Clear button can be used to start a new acquisition or to clear results. Let's look at 2 examples of Trendchart mode results. In the first example, we see that voltage, the red trace, drops when current, the blue trace, increases. In the second example, we're looking at current and the total harmonic distortion of current, and we can see an inverse relationship. Total harmonic distortion decreases when current increases. Inrush mode is used to look at the current that a device draws when it's first powered up or switched on. This time period is usually much shorter than the time periods looked at using Trendchart mode, and inrush current can be very high compared to the current drawn during steady-state operation. There are 2 ways of measuring inrush current with the NPA. The first of these is using peak hold while in numeric mode. The second is using Inrush mode. In Inrush mode, the voltage and/or current are plotted following a trigger event. This is similar to making a single-shot capture on an oscilloscope. In addition to plotting these values, Inrush mode also numerically displays the maximum voltage and current during the acquisition time. Inrush mode measurements begin on a trigger event, and this trigger must first be armed using Activate On. The trigger must be rearmed after each measurement. Settings include the acquisition time, which can be from 16 milliseconds to 67 seconds, the trigger source, which can be voltage or current, the trigger slope, rising or falling, and the trigger level in either volts or amps. Note that the Inrush current waveform data can also be exported in CSV format for offline analysis. Here are a couple of examples of Inrush mode. In the first example, we see that the current, the red trace, gradually stabilizes after an initial peak, whereas in the second example, there's a short high initial current burst, with current being relatively low and stable thereafter. The last standard measurement mode we'll look at is Harmonics mode. Harmonics are created by nonlinear loads and can create many problems in the power grid. Harmonic mode performs an FFT or fast Fourier transform in order to calculate the RMS value and phase angle of up to the first 50 harmonics. It's also possible to display only the odd or even harmonics. The cursors or rotary knob can be used to view the values for an individual harmonic, highlighted in orange. In addition to the bar chart shown here, harmonics can also be viewed in table form, showing per harmonic magnitude and phase. The bar chart displays useful in visualizing patterns. Here we see much higher amplitude of odd harmonics compared to even harmonics. Bar chart mode only shows amplitude, so tabular mode is needed if we want to see the phase angle in degrees for each individual harmonic. Next, let's spend a few minutes briefly looking at some additional features of the NPA. This includes the energy meter or integrator function, limit testing, external inputs and outputs, the use of external sensors, data logging, and remote access or control. The energy counter or integrator is a special numeric mode configured from the Measure menu, and it calculates and displays the cumulative power or energy consumption for a device under test over time. This can be helpful in determining the energy cost of a device in both active and in standby operation. The NPA calculates and reports energy consumption as positive, negative, and total watt-hours updated in real time. These results can also be logged to a file and exported for documentation or for further analysis. Another numeric mode function is limit testing, which is also configured via the Measure hard key. Limits monitor whether a measured value, such as current, power factor, etc., stays within user-specified limits. Up to 6 sets of limits can be defined, with each limit having a high and low value for the measured parameter. Limit results are displayed in two ways, both as a percentage of the limit range and as a bar graph relative to that range. For example, the RMS current limits here are defined as 0 to 400 milliamps, so a limit value of 83.8% corresponds to a measured value of 335.2 milliamps. Limit violations can also be externally signaled using the digital output connector on the rear panel. The rear panel of the NPA has 4 BNC connectors that can be used for interfacing with other test instruments or for automation. The analog in connector measures an external voltage input and displays it in numeric mode, while analog out produces a voltage which maps to a user-selected measurement value on the NPA. For example, voltage, current, or percentage of limit value, as described just a moment ago. The digital in connector can be configured to display whether the input is high or low, or it can output the frequency or duty cycle of an external pulse width modulated signal. And digital out can be used to either indicate a passing or failing limit value, or it can output the measurement frequency in the form of a square wave. The external hard key is used to configure the behavior of these inputs and outputs. The external hard key is also used to configure external sensors. An external clamp-style current probe or differential voltage probe can be connected to the sensor jacks on the front of the NPA. These probes can be used to extend the current measurement range from 20 amps up to 1000 amps. Configuration parameters for external sensors include the type of sensor, the clamp probe scaling value or shunt resistor value, and the voltage range at the sensor jack input. Measured data can be logged in the form of a CSV or comma-separated value file. Up to 10 user-defined measurements can be logged, and logging rate can be configured to a maximum of 10 measurements per second. Logging can be controlled in 3 different ways. It can be manually started and stopped. The user can specify a given number of measurements to make, or absolute start and stop times or durations can be configured. The maximum logging duration is 96 hours, and the logged CSV data can be saved to or exported via an attached USB drive. It's also possible to remotely access or remotely control the NPA via its external interfaces located on the rear panel. LAN and USB interfaces are standard, and there's an optional GPIB interface. One method of remote control is using the free HME Explorer Power Software module, which provides both graphic and numerical views. Another method is using industry-standard Skippy commands to configure the instrument, start measurements, and retrieve measurement results. Please see the documentation on these tools to learn more about their capabilities and how to use them. The NPA 701 can optionally support automated measurements for testing compliance to 3 important power standards, IEC 62301 and EN 50564, which measure energy consumption in low power or standby mode, and IEC 61032, which verifies the level of harmonic currents. These compliance tests are implemented as a menu-based, step-by-step wizard, which prompts the user for parameters and test configuration. The tests run automatically, and results can be displayed on screen in tabular form, but can also be saved and exported as an HTML file. Compliance tests are accessed by pressing the Measure Hard key, selecting Standards from the menu, and then selecting the standard to test against. Let's walk through how the wizard is used to configure a test. First, the region and voltage/current are selected, and then the user is prompted for the expected crest factor and max current. This test also requires that the pattern of power consumption, static, variable, or cyclic, be specified. A connection diagram is shown, and then the user is prompted to start the test. Measurement results are displayed in real time as the test is running, and both elapsed time and total test time are also displayed. At the end of the test, a pass-fail result is given. Any measured values which fall outside of the specified range are displayed in yellow. The measurements can then be restarted, or results can be exported to a USB drive in HTML format by selecting Save HTML from the menu. Let's end with a brief summary. The Rohde Schwarz NPA Power Analyzer can perform a wide range of power-related measurements using 5 different measurement modes: Numeric, Waveform, Trendchart, Inrush, and Harmonic. Each of these modes has user-specified configuration and measurement parameters that are entered and adjusted through the NPA's simple user interface. Additional useful functions for power measurements include a power integrator, limit testing, external input and output connectors, and data logging. In addition to the standard tests, automated conformance tests are also available for verifying compliance to various international standards for both standby power and current harmonics. This concludes our presentation, Getting Started with the NPA Power Analyzer. If you'd like to learn more about the NPA, power analysis, or other power measurement-related topics, please see the links in the video description. Thanks for watching.